All right, hi everyone. We're looking at our next kind of transformation, which is known as the translation, which specifically means this is a transformation that slides a figure a given distance. So this time our distance is going to be on our grid, and we're going to be going to the left, to the right, going up and going down. Now, before we get into actually moving our figures around, we need to talk about the notation of how these rules can be expressed when we get into those, because there's two ways you could possibly see your rules. So let's take a look at the first one for just a second. These are our coordinate rules. So your coordinate rules are based off of your original XY point, whatever it may be. We're going to change that, transform it. And by doing a translation really says we're going to add or subtract some number to the X coordinates of the original point. It also says we're going to add or subtract some number to the Y coordinate. Now, to keep in mind of the direction we're going to be moving, that plus or minus and the coordinate are very important. So if we are adding to the X, then we are going to the right. And if we are subtracting from the X, then we're going to the left. Similar idea for the Y-axis, or your Y coordinate that goes up or down. If we are in fact going up, then we're adding to the Y. And if we go down, we are subtracting to the Y. So that does give us a clue as to the direction when we have our given rules. So let's see what happens when we look at our next kind of rule, which is called vector notation. Vector notation says that we are going to jump straight to just the rules. We are not going to have the coordinates here. We'll either have our plus or minus the A value, but again, first position is still going to the X, and then plus or minus to the Y coordinate. And we put our little brackets in there. Now, again, the plus or minus does not mean positive or negative. That is something that is very specific to the vector for these transformations. So the plus sign, again, means we are adding, while the minus sign, that is not a negative, that is a minus. So just keep that in mind. It's not a positive number and a negative number. It is a plus some number and a minus some number. So let's see what happens when we bring in our pieces. And let's try out our rules with example 1. So example 1, we're going to be translating the points left 3 and then up 2. So that is our move. So remember, if we go left, that means minus, since left 3 means minus 3. Up 2 means plus 2. So when we put that into our rule, that's exactly what we're going to have. You have your original x, y there. So then we're going to take every x and subtract 3 from it. And then you have your y. The rule says up 2. So take every y and add 2 to that number. So let's do that to these coordinates and see how it's going to move. First, though, let's graph this original set of points. So we've got A is at 3, 2. B is at negative 1, 3. So there's our first line, and then 1, 0. So there's the triangle that we are going to be moving. Sorry, I did not connect that very well. There we go. So there is our original. Now let's do the translation for these and see where everything ends up. So again, minus 3 from every x. So we're going to subtract 3 from every x number. Sorry, that is a little small. I'm going to make that a little bigger to see it better. So minus 3 from each of them. And let's see what we get. So 3 minus 3 is a 0. There's my first new x coordinate. -1 minus 3 is a -4. And then the last one, 1 minus 3 is a -2. So there's the first coordinate, first part of my new coordinates. Now we're going to do the y's. For every y, we're going to add 2 to that. So for each of these, we're going to add 2 to these values. And let's see what we get. 2 plus 2 is a 4. So there's my new y. 3 plus 2 is a 5. And 0 plus 2 is a 2. So there are my new coordinates. Let's graph this new shape. So first we have 0, 4. I'm going to move the B over just because it's a little in the way here. So 0, 4 is our new A. And remember, it's got to have that apostrophe because it is the new shape. Next, our new B, B prime, -4, 5. So there is B prime. There's my first one. And then the last one, C, -2, 2. And there is our translated triangle. As you can see, the shape is still exactly the same. The two triangles are congruent. They're just sitting in different positions, but they have, as a whole, moved left and up, exactly how far it said it was supposed to go. Let's try another example, again, practicing using these points. But first, let's get our vector rule up here. So again, for vector, we just need our bracket and the physical movement. We moved -3, so all I need to write the vector is the -3 and the +2. So -3 and +2. There is our vector. That's all it takes. Let's do again one more example with redrawing our figure. Notice it's the same 3 starting points, so I'm going to get those graphed real quick. 3, 2. So there is our original A. Then we had -1, 3. And 1, 0. So same starting triangle as before. But this time, let's see how it's supposed to move. All right, so this time we are shifting this shape right 2 and down 3. So remember, right is a plus. Oh, sorry. Let me fix that. So +2, down is a minus, and 3. So we're going to add 2 to every x and subtract 3 from every y. Let's see what happens. All right, so let's +2 to all of these x's. So +2, +2, and +2. So 3 plus 2 is a 5. -1 plus 2 is a 1. 1 plus 2 is a 3. Now let's do the y's. For every y, we're subtracting 3. So -3 to each of these y coordinates. So 2 minus 3, -1. 3 minus 3 is 0. 0 minus 3, a -3. Now we have our new coordinates. Let's go graph them. So 5, -1 for my A prime. All right, so there's A prime, first point. Next one we have 1, 0. Notice B, prime, and C were fine. And then our last point, 3, negative 3. There is our C prime. And so there's our translated image. We shifted down and to the right. And again, there's nothing wrong if your points start to overlap. All right, let's look at our last example. Up until this point, you've been given the coordinates of the original and the rule to follow. You had to get your new coordinates in the new shape. This time, you're going to get your two shapes, and we're going to figure out the translation rule that's happened. Oh, but sorry, before we do that, let's get your vector up here. So we have our movement, again, +2 and -3. So +2 in the first position, -3 in the second position, and there's our vector rule. Now let's check out our last example. Example 3, write the translation rule. So let's get it set up so that we can write this rule out. So our starting point, x, y, translated to become. We're going to either add or subtract something to this x. And then let's also get your vector rule ready. So we're ready. We just need how much are we adding or subtracting to finish this rule off. Let's go count. Remember, the apostrophes, the primes, is the new shape. So if I'm looking at my EFG here at the bottom, there are no apostrophes to any of these points. So this is my old shape. All right, that is the old one. Which means the shape that is above is going to have to be the new one because it has those apostrophes. And we need to see how far did it move. So let's go corner to corner, point to point, and see what happened. How far did we go here? Let's start with E, just because it's the easiest one to find real quick. So there is E and E prime. It doesn't matter which direction you start with first. If you want to go up or down first and then left or right, either way is fine as long as you get the right distance. So we're going from E to E prime. So we can go up 1, 2, 3, 4, 5. And then to the right, 2. So again, we went up and to the right. So up 5, right 2. So again, it doesn't matter which one comes first because we will make sure it is correct when we write our rules. Let's check the other points and see if there was the same kind of movement. So from G to G prime, we have again right 2 and up 5, so it worked there. And then let's check our last one, F and F prime, right 2 and 5. So it is the same all the way around. It doesn't matter what coordinate we choose, we have the same movement. So now we can use this to write our rules. All right, so again, if we go to the right, that is a plus. We went right 2, so +2. And +2 for my vector. We went up 5. Up is a plus, so +5, and +5 for the vector. So both ways could be considered my rule. It just depends on what what rule do they want? Do they want it written in coordinate or do they want it in vector? Either of those are correct. All right, guys, I hope you enjoyed learning a little bit about translations. There's one last thing that I want to remind everybody about, because you will see this possibly come up, and that is what happens if there is no movement at all. So no movement. Again, let's say you don't move up or down, you don't go left or right, one of those possibilities, then that coordinate will not be affected. Okay, just for example, if I have x comma y plus 1, that means you only moved up 1. No right or left. So the x coordinate was not affected. So just keep that in mind. If your triangle or your shape does not move in one of the directions, then that coordinate will stay exactly as it is, almost like you were adding 0 to it. Okay, guys, so again, I hope you liked learning a little bit about your translations. Don't hesitate to reach out to me if you have any questions at all. Bye, guys.